my car.
Well, you got to come over this way by me, okay? You want to come this way? We're going to help some students out. What do you say?
Good.
This is what we do for fun on a Saturday.
All
right. Hi. So I see that quite a few of you have a lot of questions about the proportion stuff that we went over in class. And I was going to go live on Monday, but knowing that we have a test on Tuesday, I'm not sure I like the timing on that. So I figured I'm going to go ahead and make some videos tonight. And again, if anyone watches live, that's great. If not, no big deal. The videos are going to save after. So I'm not necessarily doing this to get a live audience at the moment, but I just sent an email out to some parents to let you guys know that I'd be here. And then hopefully this video afterwards is helpful for Saturday, Sunday. So I have my assistant here. Say hello, Kylie.
Hi.
All right. You hang right there, okay? All right. Where do markers go?
Okay.
Okay. You got them? Can you hold these for me, please? Okay. So we had some questions about proportions. And let me see. Hold on. I got to find where all the problems are here. All right, Kylie. I'd ask you to read these to me, but you don't know how to read all those words yet.
Okay, would this be easy?
Would this be what?
Would this be easy for me?
I mean, your job in this should be relatively easy. Okay. So I'm going to look at number 5 on page, what's this? Looks like it's the 4th page. Okay, no, it's not. I scrolled down too far, Kylie.
It's okay.
All right. Do you think they'll mind?
No, they won't mind.
Okay, I hope not. All right. So I'm going to look at number 5 on the 4th page. So this is one of the proportion problems. And again, this is something that we're going to go over again on Monday, but I figure I'll do a couple sample problems, okay? So this one says the string that produces the lowest tone on a piano vibrates 87 times in 3 seconds. So then it asks us, how many times would this string vibrate in 12 seconds? So in this situation, again, whenever I read a problem like this, I'm looking for the two things I'm comparing. Okay, because remember, ratios are a comparison of two numbers, and the two, they give us 3 different numbers here, and we have to figure out what am I looking for? I don't know. We're looking for there's 2 different things that are being compared here. There's times, like how many times something vibrates, and then the amount of seconds. Okay, so I'm going to say vibrations per second is what we're comparing. So I need you to actually scooch this way a little bit. Is that okay? All right. So we're talking about vibrations per second here. Okay. So I'm going to set my labels up first. Vibrations per second. Okay. And then it says the string that produces the lowest tone on a piano vibrates 87 times in 3 seconds. So that's the ratio I'm given. Okay. 87 times in 3 seconds. Okay. What's up?
Can I draw the stuff?
Well, why don't you come on over here then, okay? So 87 times in 3 seconds. Draw me a little smiley face down here.
Okay.
Okay. And then we want to know how many times it's going to vibrate. You have a ton of markers. I'm trying to teach them here. Anyway, we're trying to figure out how many times the string would vibrate in 12 seconds. Okay. So we want to find out 12 seconds. So I'm going to keep that on my seconds row. Okay. But again, I'm trying to find the vibration. So that's my unknown. Okay. And again, what we're trying to find here is an equivalent ratio. All right. So I'm setting these fractions equal to each other based on these labels, okay? So the only way for me to do, well, not the only way, but one of the ways to do this, and the method that you've been taught, is to cross multiply. Okay, watch out, so people trying to see. Okay, so I'm going to cross multiply these numbers, and I'm going to set them equal to each other. 3x is going to equal 87 times 12, okay? And remember, on your test, you can use a calculator. So I'm going to use a calculator to do that, okay? So I'm going to simplify what I can, which I can simplify 87 times 12, okay? And that's going to equal 1,044. All right? And that still equals 3x, all right? And this is where I think a lot of people are getting tripped up. Remember that later on this year, we're going to learn how to balance equations, okay? So to balance an equation, we have to realize that on each side of the equal sign, things are, well, they're equal. They're exactly the same, okay? They're in balance. So I have just as much stuff on this side as I do on that side, all right? So what that means is if I'm going to take something off of one side to keep it equal, I have to do the same thing to the other side, okay? So this is how we start to isolate a variable, okay, or get a variable by itself. So in this case, we want to get x by itself, and right now it's attached to a times 3. Okay, down here, sweetie, because people are trying to watch, okay? So the variable x is attached to a times 3, okay? And what we need to do is do the opposite operation with that number to get rid of it. Okay, so in this case, I'm multiplying by 3. So to get rid of it, I have to divide by 3. But what I do to this side, I have to do to that side. The reason I divide by 3 is now this cancels out, leaving x by itself. So that means whatever I do on this side now is going to leave me with the value of x, which is going to be our answer. So if I take 1,044 divided by 3, I get 348. All right? And if we look at the problem asked us how many times would this string vibrate in 12 seconds. So this would be vibrations per second, okay? Vibrations per second, okay? So if I were to put this back into the problem, okay, these fractions are now equal with one another, okay? So again, that's the goal, is to try to make an equivalent ratio. And we are using proportions to do that. And proportions is something that you did in 6th grade. So the concept shouldn't be too unfamiliar, but I can understand the confusion pulling these out of word problems. So I'm going to do one more with you. I'm going to do number 7, and this one is about Mercury, the planet. Okay. What did you want to say, Kylie? I'm sorry. Nothing? Are you sure? Okay. Can you hold my phone for me, please?
Actually, I do.
Well, then go tell me. What do you want to say?
No, I need to say something to you.
Well, whisper it in my ear. Go ahead. I guess. Okay. So let's do number 7. Number 7 says, on Mercury, you weigh 2 pounds for every 5 pounds you weigh on Earth. Okay. So now we're comparing pounds on Mercury to pounds on Earth. Okay. So we're just going to compare my weight on Mercury to my weight on Earth. Okay. So M to E. All right. And it says that you weigh 2 pounds for every 5 pounds you weigh on Earth. So there's my ratio. 2 pounds on Mercury is what I would weigh if I weighed 5 pounds on Earth. Okay, obviously I don't. I got a little bit to lose here. That's okay. All right, so now the problem asks me, you weigh 135 pounds on Earth, maybe like my junior year of high school. All right, so that's how much I weigh on Earth. Okay, and I'm trying to figure out what would I weigh on Mercury. Okay, so that's my unknown. All right, and keep in mind, pounds on Earth, 5 pounds on Earth, that's my weight on Earth. Pounds on Mercury, they say 2 pounds per every 5 on Mercury, and I want to know how much I weigh on Mercury. So again, I have to set up a proportion, find an equivalent fraction. Okay, so I'm going to cross multiply to do that. All right, and so I'm going to get 5x equals 2 times 135. So 135 times 2. And 135 times 2, what's that? Is that 270? That sounds right. I think it's 270.
Yeah, I think.
You think it's 270? I think so too. Yep, 270. I was right. All right, so I'm going to simplify this. 135 times 2 is 270, okay? And that still equals 5x. All right, and again, I'm multiplying by 5, and I want to get the variable by itself. So to get rid of multiplication, I have to do division. To get rid of the 5, I have to divide by a 5. All right, so I'm dividing by 5 here, so I can isolate x. If I do it to this side, I have to do it to that side to keep things equal. Okay, if I do something for Kylie, I better do it for Mason, or he's going to be mad. Right, Mason? That's right. Play-Doh's awesome. Okay, so 270 divided by 5. What's up, bud? Of course you can have some crackers, my man. Okay? Okay. You want me to open them for you?
Yeah.
Okay, go get the crackers. All right, this is what we do for fun on Saturday nights, okay? So x, don't be silly. So x is going to equal 54, okay? Because, again, I divided 135 times 2 by 5, and that was 270. Divided by 5, and I get 54. So on Mercury, if I weigh 135 pounds on Earth, yes, I will go get the crackers, my friend. Hey, Kylie, can you help me out here? Go get the crackers for him. They're right there. Okay. So again, 54 pounds on Mercury means I weigh 135 pounds on Earth is how that we solve that problem. Okay. Let me see. I think that those were the major issues that we had. I think we had problems with proportions is where I'm getting a lot of questions. So hopefully this gives you a little bit of this gives you two solid examples of how to do a proportion. The videos that I shared on Thursday should be helpful as well. And again, a lot of this is just pulling things out of the problem and just knowing how to line them up. And so that's why I decided to do this video tonight, again, to show you, make sure you find what you're comparing. Okay, use the information they give you. Okay, and if they give you one part of the problem, then you have to find the other part. So they gave us my weight on Earth, so that means I had to find my weight on Mercury. Okay, and they gave me 2 pounds on Mercury, per 5 pounds on Earth. So I'm able to use this by creating an equivalent fraction, okay, and an equivalent ratio in this case. So when you were in 5th and 6th grade, and even a little bit in 4th grade, you did work with equivalent fractions. So the idea of an equivalent ratio is the same thing, because we're using fractional ratios, fractional rates. So you've done work with fractions before. The rules have not changed for that. But I understand if there's some confusion with how to pull this stuff out of problems. So should we do one more, Kylie? What do you think?
Yes, I think so.
You sure? Mason, you got your crackers? Are they good? Can I have one too, please? All right, thanks, buddy. All right, so we'll do one more. We'll do number 9. So this is the top of the 5th page of the work I gave you. Okay, and I can't see the chat. Hopefully everyone's behaving themselves. How's your day? Well, it's pretty good, Mr. Carvajal. Hopefully your day is going well too. Oh, thanks, guys. Excellent. Thank you. I needed that. Okay, that'll get me through the next problem. All right. So again, we're looking at problem number 9. Okay. We're going to set it up the exact same way. A hybrid car uses 1 gallon of gas to drive 54 miles. Okay, so that first sentence gave me 2 labels: gallons of gas and miles. Okay, so I'm comparing gallons to miles. Okay. So it says a hybrid car uses 1 gallon of gasoline to drive 54 miles. What's so funny? Here, let them see you. Say hi, Mason.
Hi, Day.
Hi. You're saying hi to my students. Okay. So again, a hybrid car uses 1 gallon of gasoline to drive 54 miles. So 1 gallon of gasoline for 54 miles. Okay. And we're trying to figure out what's that going to equal. Okay.
Oh, no.
All right, guys, come on, help me out. Help me out a little bit here. Wait, go get your crackers. Okay, so again, they gave us 1 gallon of gasoline to drive 54 miles, and it says how many gallons of gasoline would be used to travel 162 miles. So they gave us 162 miles, all right, and they want us to know how many gallons of gas that would be. Okay, so again, this is the information I'm getting directly from the problem, and I'm just plugging it in and I'm setting it up according to the labels given in the problem. Okay, so now, again, I can use math to solve this. I can use cross multiplication. All right, so I'm going to cross multiply. 162 times 1 is 162, so that was easy. Okay, and I'm comparing that to 54x. Okay, Kylie, my phone, please.
Here we go.
Thank you, dear. Okay, so now I'm going to take, I have to get rid of this 54 that I'm multiplying by the x. So to get rid of multiplication, we divide using the same number. Okay. So we're going to get rid of that, and now x is going to equal this number divided by 54, because what I do to this side of the equation, I have to do to the other to keep it even. Okay, so 162 divided by 54 equals 3. Okay, and what this 3 means is, it means that for every, because again, the problem told us for every 1 gallon of gas, I can go 54 miles. That is a great gas mileage, by the way. So 1 gallon of gas for 54 miles. So if I had 3 gallons of gas, I could go 162 miles because these are equivalent ratios. Okay. So I hope that answered a few of your questions. Hopefully that gets you through the weekend. And don't forget, we are going to go over this stuff on Monday too. And again, this is for Math 7. So I see I have one Math 8 student here, but thanks for joining the party. Your live stream will be on. What are you doing? Your live stream will be on Tuesday, I believe. But thanks for joining. And hopefully this helps you guys out. This is my buddy Mason. You say hi, Mason. All right. What are we doing tonight? We gonna go watch a movie?
Yeah.
All right. So this is our movie night. So we're gonna go watch a movie now. What are we watching? What are we watching? Tell the people.
The other half of the Hobbit movie.
You have to show me your Infinity Stones on your cast too. Here you go. There's Kylie's Infinity Stones, Time Stones right over here. There you go. Okay. So we're gonna go watch our movie, but hopefully these 3 example problems helped you. If you have any questions, watch these again, I guess. Okay. And give these other problems a shot. 'Cause like I said, if you come up with questions on Monday, that's okay. We'll get those answered, and hopefully we'll be ready to go by then. So. We already watched The Great Railway Show, man.
Yeah.
Okay. No, not 7-year-olds. Math 7 is 7th grade. Math 8 is 8th grade. So, let me see. She can't even snap. Oh, they said you can't snap your fingers.
They would just yeah.
How you gonna snap if you got the cast on? That's a good point.
Green.
All right. Well, we're out of here. You guys have a good weekend, and I'll see you Monday to get any more questions answered.
I didn't see that they said that.